So let me ask you a few questions. What if you could teleport to the surface of the sun, but only for a billionth of a second? Or what if every single human on Earth just vanished? How long would our lights even stay on? And what do you think is more dangerous, floating up into space or digging straight down into the Earth's core?
Well, that's exactly what we're doing today. We're going to dive into these bizarre, extreme hypotheticals to see what the laws of physics actually have to say about survival. Our little journey is going to take us right to the edge of what's possible.
So here's what's on the menu. We're going to take a ridiculously fast trip to the sun, then we'll compare two very slow but very deadly journeys, and finally, we'll stick around to see the very last light on a world without us.
All right, first up, we've got a scenario that just seems like an obvious death sentence, but, there's a pretty surprising twist. Okay, let's really think about this. A nanosecond is 1/1000th of a second. The sun's surface is a scorching 5,800 Kelvin. So if you just popped over there for that tiny, tiny instant, you're toast, right? Has to be.
Believe it or not, you'd be fine. You would absolutely survive. You wouldn't even get warmed up. And the reason why? Well, it's all about time.
To really get this, you have to appreciate just how insanely short a nanosecond is. Light itself, the fastest thing in the universe, only travels about a foot in that time. The total energy you would absorb is something like 100,000 times weaker than what you'd need for even a second-degree burn. You'd see a tiny flash of light, sure, but here's the kicker. It would take your brain 30 million nanoseconds just to process that the flash even happened. By then, you're long gone. You're already back home.
So yeah, you survive the surface, but this little trip comes with a terrifyingly, unbelievably small margin of error. What happens if you miss your target and end up inside the sun?
Inside the sun's core, where temperatures hit millions of degrees, you'd get a second-degree burn in 1 femtosecond. A femtosecond is a millionth of a nanosecond. Remember, you're supposed to be there for a whole nanosecond. That's a million femtoseconds long. Yeah, this does not end well for you.
And here's the truly wild part. It's not even the heat that gets you first. Nope. Deep in the sun, all that energy is carried by high-energy X-rays. These things would just instantly blast right through your body, literally shredding your DNA at the atomic level. They'd cause catastrophic internal damage before your skin even had time to register that it was hot.
Okay, let's switch gears from an impossibly fast trip to an incredibly slow one. Imagine you start moving at a steady 1 foot per second. No speeding up, just a slow, constant drift. But you have two choices, straight up or straight down. Which direction kills you first?
Now, floating up seems kind of peaceful, right? But you're heading for the cold, airless vacuum of space. Digging down avoids that, sure, but you're heading towards the Earth's fiery core. So let's break down the journey up first. Going up is a pretty slow burn, relatively speaking. After about 2 hours, you'd hit freezing temperatures. If you weren't wearing a really warm coat, hypothermia would probably get you around the 5-hour mark. But if you are bundled up, you'll last for about 8 hours. That's when you reach the death zone above 8,000 meters. We're talking Mount Everest altitude here, where the air is simply too thin to breathe. You'd suffocate.
8 hours to die going up. That might sound pretty bad, but let me tell you, compared to going down, it's a luxury cruise. Digging down presents immediate, and I mean immediate, insurmountable problems.
And this chart just lays it out perfectly. First, there's the heat. The ground gets hotter by about 35 degrees Celsius for every kilometer you go down. You'd be cooked in just a couple of hours. But okay, even if you could somehow solve the heat problem, you run smack into the second issue. Just sheer power. After only 10 minutes, you'd need over a megawatt of power just to lift the rock you're digging through. And finally, even if you solved all that, you'd face toxic air. At 15 kilometers deep, the atmospheric pressure gets so high that the very oxygen you need to breathe becomes poisonous.
All right, for our final scenario, we're zooming out, from the personal to the planetary. Let's imagine that one day, poof, all 8 billion humans are just gone. What happens to the world we built? And more specifically, what happens to our lights? When would the very last flicker of humanity's presence finally fade to black? You know, the answer is much, much later than you probably think.
So, the first big blackout would happen fast. Within hours, major power grids would have cascading failures without us there to manage them. Any off-grid diesel generators might last for a few months. Really robust systems, like geothermal plants or big hydroelectric dams, could maybe run for a few years before their machinery just seizes up. The longest-lasting conventional lights? Probably something solar-powered. In a nice, dry, windy spot, a well-built solar panel could keep a light blinking for a whole century. But even that is not our final light.
No, the true last light isn't a testament to our amazing engineering. It's actually a strange and kind of eerie byproduct of our most dangerous technology.
And this light comes from something called Cherenkov radiation. It's what happens when high-energy radioactive particles move through something like water or glass. They create this beautiful, distinctive blue glow. The best way to think of it is like a sonic boom, but for light. It's an optical shockwave that gives off this incredible glow.
And the source of this final light? It's our spent nuclear fuel. Highly radioactive waste, stuff like cesium-137, is often melted down into solid glass blocks for long-term storage. And deep inside their concrete vaults, these blocks glow with that eerie blue light.
Cesium-137 has a half-life of 30 years. That means for more than 200 years, 2 whole centuries after we're gone, deep inside these concrete storage vaults, these blocks of our most toxic waste will still be glowing faintly, casting the very last artificial light on Earth.
So, what have we learned today? Well, we learned that time can protect you from incredible heat, but not from radiation. That digging down into our own planet is way more dangerous than just floating away from it. And that maybe, just maybe, our longest-lasting legacy won't be some grand monument, but the faint blue glow of our own trash.
You know, these thought experiments show us a universe that's far stranger and more counterintuitive than we usually imagine. A place where a billionth of a second or a single foot can be the difference between life and total oblivion. So I'm curious, which one of these scenarios surprised you the most? Let us know down in the comments. Thanks for exploring the impossible with us today.